The last class.
Really? I've not sent it.
Yes, sir.
Oh, okay. I will send it along with this.
Send that one first.
What is it?
Send that the last class first.
I didn't get you.
No, you said you will send it alongside with this one now.
Yes. I said I will send the video. I don't start with this one.
Okay. But I was telling you to send that one first.
Okay. No problem. So when we say portfolio is a collection of 2 or more investments. When you have more than one investment, we said you have a portfolio of investment. Okay. You have more than one investment, then we can describe you as a portfolio holder. So before we can portfolio, it means there must be more than one investment. Now, investment can be investment in stock. It can be investment in shares. It can be investment on non-current assets. It can be investment on projects. Any kind of investment at all. Okay. Investment can take any form. So when we say investment, it does not, it's not limited to say maybe you are buying shares or you are buying bonds. So it can be investment in anything at all. Okay. Now, when you have a portfolio of investment, or let me put it this way, as an investor, you are expected to construct your portfolio in such a way that your level of risk will be at the barest minimum. You are expected to complete your portfolio, to construct your portfolio in such a way that the risk of the portfolio will be at the barest minimum. You know, for every investment you have, there is a risk attached to it. So every investment has a risk. So if you're not having more than one investment, it means you're having more than one risk. So if you have investment A, investment B, investment C in your portfolio, so it means the portfolio is also comprising risk of what? Investment A, B, and C. Now, as an investor, you are expected to make sure that the risk of all the investment in your portfolio is at a minimum acceptable amount of risk. And that is the reason of diversification. Diversification simply means investing in more than one investment in order to reduce risk. I'll take it again. When we say diversification means investment in more than one investment in order to reduce risk. That is what we call diversification. And for diversification to take place, the company is said to have invested on various investments that are either negatively correlated or that are having zero correlation. If I have investment A and I have investment B, before I can say that I have diversified, the two investments I'm having, both investment A and investment B, the correlation coefficient of the two investments must be either 0 or less than 1. That is when I will say I have diversified. But if my correlation coefficient is positive, that is greater than 1, then you have not diversified. Okay? You have not diversified. For diversification to take place, the correlation coefficient of all the investments in the portfolio must either be 0 or negative. Now, we are going to see what we mean by positive correlation and negative correlation and zero correlation. When we say correlation, generally, what correlation measures is the degree of movement of the return of the investment that make up the portfolio. Okay? Correlation measures the degree of movement of the investment return of all the investments that make up the portfolio. Hello, can you hear me? Are you getting what I'm saying?
We are hearing you, sir.
Okay. That's what we call correlation. For instance, if I have investment A and investment B, if the return of the two investments are moving in the same direction, in the sense that if the return of A is increasing, the return of B is also increasing. In that case, I have not diversified. Now, when we say positive correlation exists where the return of all the investments that make up the portfolio are moving in the same direction. In the sense that when the return on one is increasing, the return on the other is also increasing. That is positive correlation. So when you compute your correlation coefficient and the result is plus, that is positive figure, then it will be interpreted to mean that the investment have a positive correlation. What about negative correlation? Negative correlation simply means when the investment return, or let me say, when the correlation coefficient is negative, in the sense that when return on one is increasing, the return on the other is decreasing. If I have investment A and investment B, and I discover that when the return of investment A is going up, the return on investment B is going down. That is a negative correlation. It means the two return of the investment are moving in the opposite direction. They are not moving in the same direction. So if your return on investment is not moving in the same direction, we say the investments are negatively correlated. they are negatively correlated. Now, when we say zero correlation is where you cannot even determine the pattern of movement of the investment return. Okay, they are neither positively correlated nor negatively correlated. Okay, when you have investment return that are neither positively correlated nor negatively correlated, then the investment will be said to have a zero correlation. And it interpreted to mean that the return on the investment, the movement of the return on the investment cannot be what? Cannot be established. So out of the three, positive correlation, negative correlation, and zero correlation, negative correlation and zero correlation are the one that is applicable when we are talking about diversification. Now, we have two types of risk on investment. We have two types of risk on investment. Number one, we have what we call the systematic business risk. And when we talk about systematic business risk, is a risk that affect all the companies in the market in the same way. So a systematic business risk affect all the companies in the industry. The industry is what we refer to as market A. So it affects all the companies in the industry. That kind of risk is what we call systematic business risk. So systematic businesses cannot be diversified. That is why sometimes it is referred to as undiversifiable risk, because you cannot run away from it, except you do not invest in the industry. The moment you invest in the industry, you are facing the systematic business risk of that industry. Then we have unsystematic risk. Unsystematic risk affect a particular company. It affects a particular company, not the market in general. So that's the distinction between systematic risk and non-systematic risk. Okay. I've explained correlation, use it. Now, let us look at when you have investment and you want to measure the risk of the investment. How do you measure the risk? The risk of an investment or the portfolio from three perspectives. Number one, you can measure your risk using standard deviation approach. You can measure risk using what? Using standard deviation. And what is the meaning of standard deviation? Standard deviation simply means the degree of the difference between the expected return and the actual return. The deviation between your expected return and your actual return or required return is what we call standard deviation. If my expectation is 30% and I end up getting 20, then my deviation is 10%. Do you understand this? Hello?
Hello, sir.
Okay. Any questions so far?
No question.
Okay. So that's number one way of measuring investment risk, standard deviation. The second one is what? Correlation coefficient. Correlation coefficient. Correlation is, like I defined earlier, the degree of movement of the return on all the investment that make up your portfolio. And correlation is computed as, this is the formula for your correlation. Covariance of A and B, we call it AB, COV, AB. You can abbreviate it as COV, AB. COV, AB. COV, AB. That means correlation coefficient of sorry. Standard deviation of A times standard deviation of B. Correlation coefficient of investment A and B. That's the formula for computing correlation coefficient. Now, how to compute covariance? Sorry. If you want to compute covariance, you just make this covariance the subject of the formula. So covariance AB be equal to correlation coefficient of AB. You can write this one here. You can write this one here as small letter R AB. Small letter R AB. That's correlation coefficient of investment A and B. Small letter R AB. Please put this formula in your note. Put the formula in your notes. Write the formula down, please. Don't just put it in your notes. Or have you written it? Hello?
That's what we are doing, sir.
Okay, yeah. You can abbreviate it too. It's not necessary that you write it long like this. I told you this one is what? R, small letter R, A, B. Small letter R, A, B is equal to COV, COV, A, B. This is sign for standard deviation. Standard deviation of A times standard deviation of B. Standard deviation of A times standard deviation of B. That's what to give you correlation.
Okay, sir.
Okay. Now, covariance, what does it measure? We have seen what standard deviation measure. What does covariance measure? Covariance measures the extent to which the return on two investments could vary or move Just like we have it under what? Under action. You can have what we call positive covariance, you can have negative covariance, you can have zero covariance. Majorly, the difference between covariance and correlation is that correlation will just tell you that this investment is having this two or more investment, this portfolio is having a positive correlation. They move together. It will not tell you the of movement. Covariance will let you know that this is the degree of movement. Is it and is the movement too or the movement is not too significant? It is covariance that will let you know. But you cannot get that from correlation. Now, we have this formula to compute covariance. Covariance formula is given as, for instance, covariance AB, that is an alternative to this. You know, I told you that you can make this one the subject of the formula and say RAB is equal to standard deviation of A times standard deviation of B to get your covariance. You can equally use this formula here. This one means P represents probability. I think, okay, it's even defined here. P into bracket A minus A bar. This simply means, this one you are seeing here, simply means expected return on A. And this one means expected return on B. Okay? Expected return on A, expected return on B. Times probability will give you the covariance. Now, don't worry. We solve a question that will address all this formula. Now, two asset portfolio. In your examination, ICANN is going to limit you to two asset portfolio. Two asset portfolio means a portfolio of just two investments. A portfolio of just two investments. A portfolio of just two investments. Okay? Now, when you have a portfolio that comprises of two investments, for instance, investment A, investment B, you can calculate the expected return on the portfolio. You can also calculate the risk of the portfolio. Okay, please give me just 1 minute. Let me take my this thing. Just 1 minute. Okay, so you can calculate the return on the portfolio, like I said, and you can also calculate the risk of the portfolio. You can also calculate the risk of the portfolio. How do I calculate the return, the expected return on the portfolio? How do I calculate that? The expected return on portfolio is given as expected return on portfolio. The other formula here, that you can write it. Okay, look at it here. Now let me open my work note. I want to calculate my expected return on portfolio, I want to calculate my expected return on portfolio is R. That R, you put line on it. You understand what I mean? The R there, put a line on it. That is R bar. Okay? R bar. You now put P. R bar P represent return on portfolio. P there represent the portfolio. So RP, the R there, you put line on it. That the line is what is making it expected return. Anything expected, you put bar on it. So R bar P is equal to, I told you we are limiting ourselves to what? 2 asset portfolio. This is equal to R bar A. So on that R also put what? Put bar. Okay, put bar on the R. Put bar on the R. That will mean return on as investment A. Then I have times WA. WA represents weight of A. What do you mean by weight of A? Okay, I will explain, don't worry. Times weight of A. I now say plus RB. So that on that R also put bar to represent return on asset B or return on investment B. When I say asset, I'm referring to investment. We use them interchangeably. So if I say asset here, what I'm referring to is investment. Okay, let me make it big so that you can see very well. Okay. So I now times open bracket 1 minus weight of A. 1 minus weight of A. This is how to compute your return on portfolio. That's how to compute your return on portfolio. Return on portfolio is equal to return on asset A times weight of A plus return on asset B times 1 minus weight of asset A. Now, let me explain what I mean by this now. This and this. Let me explain them. When I say weight of A simply means the proportion of my money that I have invested on A. If I have 1,000 naira, if this is the amount I have, and I've decided to invest, decided to invest on asset A, I invested 400 naira. And on asset B, I invested 600 naira. What is the weight? The weight is the portion that I have invested in A and the proportion that I've invested in B. Look at it. The proportion of my investment in A will be what? Will simply be proportion of A will simply be 400 over 1,000 times 100. That is 40%. That is the weight. It means the proportion of my investment in A is 40%. If that is the case, what is the proportion of my investment in B? If I know the weight of A, weight of B, this one here, 1, let me copy it. This one here will simply be 1 minus 40%, which is 0.4. 1 minus 40% is what? We can see that that weight of A is what? Is 40%. So 1 minus 40% will be 0.6 or 60%. So that's what the formula represents. WA is weight of A. If I know the weight of A and I want to get weight of B, I will simply subtract weight of A from 1 because the two must sum up to 100%, which is 1. So weight of A plus weight of B must be 1. And that's what we have here. 40 plus 60 is 100%, which is 1. It's 100%, which is 1. Look at it. Any question?
No, sir.
Mrs. Angela, any question so far?
No question.
Okay, thank you. So, now assumption of portfolio. Assumption of portfolio. The assumption of portfolio include investors are rational and risk averse. When we say investors are risk averse, what does it mean? Investors do not take a risk, excessive amount of risk. Okay, investors try to minimize risk. They don't take an excessive amount of risk. That is one of the assumptions of portfolio. If investors are not risk averse, then there will not be need for us to be doing portfolio theory. It is because investors are risk averse. That is why we are doing. That's why we are doing a portfolio theory to see how they can minimize their risk. That is one of the assumptions of portfolio theory. The second assumption of portfolio theory is that there is no transaction cost. Okay, I've jumped on. Investor will always seek to maximize utility. That is, investor will always seek to maximize their return on portfolio. Okay, at all times, I want to ensure that the return I'm getting on all my investment is at the highest. Is at the highest. So that's the second assumption. Investors are always seeking to maximize return on their investment. That's what point number 2 is trying to say. Number 3, risk is measured by standard deviation. Risk is measured by standard deviation. We have explained standard deviation before. 4, there is no transaction cost, meaning that if you want to buy security and you want to sell, there is no cost attached to buying or selling. You can buy. It means that you are paying you. It does not mean that you are going to take free. it simply means that you are not going to spend transaction costs, maybe issue cost. Do you understand? That's what it means. And next is what? There is no taxation. So in portfolio theory, we don't consider taxation. We assume the world exists without tax. So we are using M&M proposition 1. Don't mind me. We're not using M&M proposition 1. You know, that is one of the assumptions of M&M proposition 1. So we are applying that assumption here. So all investors are sufficiently diversified, meaning that because we have assumed that investors are what? Are rational, they will have diversified their investment portfolio. These are the assumptions of portfolio theory. Now, let us look at what we mean by the capital market line. Capital market line. A capital market line explains the trade-off between return and risk available as a result of efficient use of the capital market. Okay? It explains the relationship between return and risk. Okay? As a result of efficient use of capital market. Now, the capital market line traces out all optimal risk return combination only. What we are saying here is that when we talk about the capital market line look at the points on the graph. I won't be able to draw the graph here. Unfortunately, I don't have the graph on the note. I always draw the graph for physical. So there's no way I can draw the graph here. But what the graph simply means is that looking at the graph where the risk and your return, that is return with respect to your risk, will be at the maximum. Okay, the point on the capital market line graph where your return is going to be at the highest is what we call the capital market line. So it traces out all optimal risk return combinations only for those portfolios that are efficient. Okay, this one can only come in theory. So just try and know the definition. You don't have to know the detail of that. Now, for the capital market line, this is the formula for capital market line, which is what? RF. What is RF? RF simply means risk-free rate. Because into bracket RM minus RF, RM minus RF, which is risk premium. You already know this. Times standard deviation of the portfolio over standard deviation of the market. That is the formula for what do I call it? That's the formula for capital market line. That's the formula for capital market line. Okay. Let's look at this example. State two required conditions for the total elimination of risk in a portfolio or investment. Can you tell me the two conditions? I told you that for investor to eliminate risk, the correlation coefficient of the investment must be either negatively correlated or zero correlated. These are the two conditions. When you have the correlation coefficient to be negative or to be zero, then there is elimination of risk. Okay. B, the management of A's PSC is evaluating two projects whose return depend on the future state of the economy. We have probability. These are probability. This is the internal rate of return. It simply means return on A. Return on A, this is return on B. It's a short question. Explain, that's requirement. Explain how a portfolio should be constructed to produce an expected return of 20%. Look at this formula I gave you for return on portfolio. The question is now saying that, how should I construct my portfolio in such a way that I'll be able to get expected return of 20% on that portfolio? How should I construct the portfolio? That's the question. How should I construct the portfolio such that my return on the portfolio will be 20%? How should I do that? What this question simply means is that what should be the proportion of A and what should be the proportion of B? Meaning that the amount I want to invest, what percentage of it should I invest on A? And what percentage of it should I invest on B so that I'll be able to get 20% return on my portfolio? So this is what we are going to do. Let me remove all these ones. Portfolio 2. We have agreed that we are also meeting tomorrow, Abby. So that is the agreement, right?
During the night or daytime?
Eh?
Is it night or daytime?
No, the same time, but it will be around 9:30. I want to make sure like you have 1 week to read. That's what I'm trying to do. I'm very sure that you have not revised all what we have done now, Abby. Or have you revised? Are you up to date in your revision? That is the issue. What you have covered, I know you have not got time to revise. It's not that I don't want to revise, but there's no time. Even myself, I'm battling with myself. You can see the time I started this lecture. That is the time I just got to. I got home, I started it. So all of us, we don't have time. So our time is a major factor. I've been out since 6 o'clock today. I go by 10:30. Start early. So you just have to squeeze your time to ensure that you revise. It's just one of the way you write the exam on the 17th now. By God's grace, you are no longer writing it again.
Amen.
So, portfolio theory and CAPM. A. That's example 1. One A. So what 1A simply means that I want to compute what? I want to compute the weight of investment A and B. The weight of investment A and B. So I will come here. The first thing I need to compute, if you look at the question, you can see how the question is given. You need to go and compute expected return on A and expected return on B. You see that is where I gave you the question now. Expected return on A, expected return on B. That's the first thing you need to go and compute. How do we do that? I repeat the probability. I multiply by what? By the return. Pick this one, multiply by this. Pick this one again, multiply by this. I will now add all what I have here. I will add it together. That's my expected return on A. I do the same to B. This times 35, 40 times 15, 30% times 20. I add everything together there. I get return, expected return on expected return on B. Can you quickly calculate that? Can you quickly calculate that? Calculate it and give me your answer. Calculate expected return on A and expected return on B. Are you computing it?
Yes, sir. Expected return for A.
Okay, it's what?
Is it the total or the individual?
No, the total. When you multiply by those probabilities, you add everything together. Do you understand?
Yes, sir. What is that? 16.8
16.8. Okay. So
for A.
60.8%.
For B.
For B is what?
22.5.
22.
22.5.
Okay. I've gotten my expected return. Now, what I now want to get is the weight. For me to get the weight, I will simply say I will use a letter to represent the weight of. So let me use W to represent the weight of A here. Let W the proportion of investment. The proportion of investment. Okay, let me say proportion of fund. Proportion of fund invested in asset A. Okay, so it therefore means that return on portfolio, which are given as 20% in the question, should be equal to expected return on A, which is 16.8% times weight of A, which is W, plus expected return on B, which is 32.5% times 1 minus W. So I will have 20% to be equal to 16.8 W. 16.8 W that is return on expected return on investment A times the weight of fund investment A. Then R plus, I will use this 22.5 to open this bracket. So it will be 22.5 times 1, 22.5 times W. So I have 22.5% minus 22.5 W. So we have 20 to be equal to Now, I can collect lifetimes from here. I will have, if I collect my lifetime, I will have 20% minus 22.5%. If I collect the lifetimes, that will be equal to 16.8 W minus 22.5 W. So this is going to give me 2.5% is equal to, remove this from this, 5.7. You can confirm it, please.
5.7.
Okay. 5.7 5.7 W. So I will now divide both sides by 5.7. Therefore, my W will be equal to 2.5 divided by 5.7. That will give us what? What do we have? Where you divide?
Three. Sorry. 3.5 divided by 5.7. 0.439.
0.439.
Yes,
So we
sir.
can approximate it to 0.44. Is 0.44 is written as 40%. That's the percentage of my fund I will need to invest on asset A. Any question on that before we continue?
Sir,
Yeah.
actually, I did not understand what we were looking for. Sir,
Yes. What is it? I can hear you.
I said,
I'm waiting for you now to give me the other one. I said this is what?
I didn't understand what we are looking for in this question.
In this question.
Yes, sir.
Look at it now. They've given us, I said this is what we're looking for. That's why I'm bolding it. You can see I put it in bold. The weight, the proportion, look at it. Look at this expression now. What did I put there? Let W represent the proportion of your fund. The money you have, the percentage of it that you are putting in your investment A. That's what I used that 1,000 to what? To explain earlier now. Where I say if you have 1,000, you put 400 on A, you put 600 on B. That's what, I'm looking at the proportion of my fund that I will invest on A and the proportion of my fund that I will invest on B, so that I'll be able to get 20% return on the two.
Okay.
That's what we're looking for. And we have been able to get it from here now that I should spend 40% of my money on A. 40% of my money should be spent on A. So if 40% of my money should be spent on A, what percentage should be spent on B? So that's weight of what? That's what of B. And that is what is given as what? 1 minus weight of A. One minus weight of A. So my 1 minus weight of A will be 1 minus the proportion of my money that I'm putting on A, which is what? 0.4. So let's go to what? 0.6. 0.6 or 60%. So for me to get a return of 20% on my portfolio, I will need to spend 40% of my money on investment A and 60% of my money on investment B. If you go and do this now, if you take 40% of this and you take 60% of this, it will give you 20%. You can try it. Try, confirm it. Confirm it. Confirm it and give me what we have.
Okay.
Did you get it? Did you get it? Hello?
Hello, sir.
Did you get it 20%?
I'm still doing it.
Okay. Where is Mrs. Angela? Miss Angela, are you there?
Yes, sir.
I don't hear your voice today.
Okay. I got like 20 points. 22.
20 points.
22.
Yeah, yes, 20%, approximately 20%.
Okay.
So that is the amount, that's the percentage you need to invest on A and B, so that the return of the portfolio, sorry, the return on the portfolio will be what? 20%.
Okay.
Mrs. Angela, did you confirm that figure?
No,
Where confirm it? What happened today? You're not
I didn't
active.
even I didn't understand what you said.
You said?
What did you say we should confirm?
Mrs. Angela, talk now. I can't hear you.
I said you said I should confirm something. What did you say I should confirm? What I should confirm?
Just did now. 40% of A, 60% of B. Look at it, whether it will give you 20%. It means you are not following us.
Mm.
It means you are not following us. 40% of A, 60% of B. Check whether it will give out that 20%. Mrs. Chu, you understand what I mean?
Yes, sir.
So, Mrs. Anja, please make sure you are following us. Portfolio theory is constant in the exam. Are you confirming it?
20.22.
Exactly.
20.22.
Which is approximately 20%. So if I want to get return of 20% of my portfolio, I should invest 44%, 40% on investment A, and 60% of my money should be invested on investment B. If I do that, I will get a total return of my portfolio to be what? 20%. Now let's go to the second requirement. That's requirement A. Where is the second requirement? Calculate correlation between A and B and assess the risk of the portfolio. Calculate the correlation between A and B and assess the risk of the portfolio. Are you there?
Yes.
Okay. So let's calculate correlation. Now, if you look at, let me go back to that note. Look at the formula for correlation. I want to take you back to the formula. Look at the formula for correlation. Is that the formula for correlation, Abby? Before I can calculate my correlation, I must know my what? I must know my covariance. I must know my standard deviation of A. I must know standard deviation of B. If you don't know that, for this question, you cannot calculate the correlation. So the first thing we need to go and do now is to calculate standard deviation first. So let me go there. B. Computation of correlation coefficient. How will I calculate my correlation coefficient? Now, to calculate correlation coefficient, let me put the note there. To calculate correlation, we must first compute or calculate the standard deviation and covariance. So let me give the formula here. My correlation ordinary is given as RAB. RAB is equal to covariance AB all over covariance AB over standard deviation of A plus standard deviation of B. So our first task is to go and compute standard deviation for these two investments. How do we compute standard deviation? This is what I'm going to do. One, two, three, 4, 5. Yeah, this should do. I want to compute standard deviation. I will have my IRR, that's return, IRR, of A. IRR of A will not just, because I'm dealing with A first, internal rate of return of A, which is the return there. Then I will have probability. I will have expected value. That is expected return on A. Expected return on A. Okay. Then I will have my deviation. Deviation is simply let me adjust this so that I will have more space. So deviation is simply IRR of A is simply IRR of A minus expected return on A. That's the total expected return on A. That's what I'm going to have for this. That's what I'm going to have for that. Then the last column here will now represent variance. The last column will represent variance. Variance means that you are squaring your deviation. This is deviation, this is variance. So this one is of square. Now, let's bring the IRR. Is 27.185, 27.18, What about the probability? 0.3, 0.4, 0.3. What is the expected value? Expected value is the product of the two distinct. Well, let's multiply. Let me get my calculator.
Eight 8.1.
The first one, Abby?
Yes, sir.
8.1.
Yes, sir.
1. The second one, go.
7.2.
7.2. And then the third one?
1.5.
1.5. So when you now add everything together, if you add everything together, what will it give you?
16.8.
16.8. That's the expected return, Abby. So
Yes.
you will not be subtracting the expected return from each of these. You will pick this one minus expected return. That is the deviation. That's what we mean by deviation. That's what I put there. IRR minus what I put there. IRR minus expected return. Do you understand?
Yes, sir.
So 27 minus 16.8 will give me what? 27 minus 16.8 will give me what?
10.2.
10.2. 18 minus 16.8 will give me what?
1.2.
1.2.
1.2. 5 minus 16.8 will give me what?
Minus
11.8.
Minus 11, have you?
Yes, sir.
0.8.
So I will now come and square it here. You can see this one is square, abi? This one is having square. Whatever you have here is going to be squared. Come on, square it. So what is 10.2 square? What is 10.2 square?
104.04.
One what?
104.04.
104.04. What about the second one? 1.2 square.
1.44.
1.44. The third one is what?
But, huh?
The third one.
139.24.
139.
Wait, sir.
I'm supposed to have one more column. Please, let's modify the. Let me do it here so that because of space. If you get the, you need to multiply by probability. Eh? Hello?
Sir.
When you square this, let me see. Can this one contain? Can I get another column from here? I'm coming. Okay. I think I should be able to get it. I'm coming. Yes. I just kiss you like this. Yes. Better. Yes, I just kiss you like this. Okay. Let me add one more column. We need one more column to be right. Yes, good. So whatever we have here, whatever you have here you come and multiply by probability. So this times probability. Yeah, let's continue. Well, give me this one. 11.2 square is what?
139.24.
139.24. So you now multiply by the probability. This now times 0.3. Give you what?
Say 1.212.
Eh?
81.212.
81.
31. 31.
Okay, 31, I mean. 31.212, right? Next one, 1.44 times 0.4. 1.44 times 0.4.
0.576.
Eh?
0.576.
0.576. Then 139.24 times 0.3.
41.772.
41.772. You now add everything together. That's the variance. That's what we call variance. So my variance, that's how to compute variance. Add everything together. What do we have?
73.56.
13.
73.
73.56. Okay.
73. 73.
73.56. 73.56. 73.56.
We square it, you get 8.5.
You say?
So if you square it to get standard deviation, you get 8.5.
If you square it or if you take the square root.
8.5.
Okay. So I will now say my standard deviation is equal to square root of 73.56. That's 8 point what?
8.5.
8.5. Okay, 8.57. Is that correct?
Yes, sir.
Yes.
Okay. That is the standard deviation of investment A. That is standard deviation of investment A. You do the same thing for B. If I want to do for B now, I simply come here, I copy everything here. I don't waste my time. Copy. Paste. What's this one, where you have A, just change it to B. Just change this to B. B. Change it to B. Did you understand that first one? That's how to compute standard deviation. That's how to compute standard deviation. Okay. So what are the returns for B? The return for B are 35, 15, 20. 25, 15, 20. So the probability remains the same. So let's calculate the expected return of B. 35 times 0.3 will give me what? Hello?
10.05.
10.05. Okay. Second one, 15
So
times 0.5.
5. So
It's 10.5. 10.5.
10 point what?
10.5.
Oh, okay. 10.5. What about the second one?
6. Six.
Hello? Oh, yeah, now.
It's 6.
The same what?
6. 6.
Okay, just 6, Abby.
Yes.
Okay, what about the third one?
6.
6 as well.
Yes.
Oh, yeah. What is the total?
22.5.
What's the total?
22.5. 22.5.
Okay. So what is the total?
22.5.
2.5. So what is going to be the deviation? You know how to calculate it, Abby? You pick this, you remove this from it. Pick this, remove this from it. Pick this, remove this from it. That represents your deviation. Oh yeah, oh yeah, oh yeah, let's do fast.
12.5.
10 point.
12.5.
12.5, okay. 12.5. Next.
Minus 7.5.
Minus 7.5. Okay.
2.5.
2.5. We are now square them. Square the result. 12.5 square is what? 12.5 square is what?
156.25.
One what?
156.25.
Okay. Second one.
Minus 56.25.
No, it cannot be minus. When you square minus, it becomes plus now. When you square minus, it cannot be minus again. It will change to plus. If you use your calculator, put minus 7.5 square equal to, it will never be minus for you. Hello? Hello?
56.25.
Mm-hmm.
56.25.
56.25. And the last one, please take note to when you square minus, you don't get minus, you don't put minus, otherwise your result will be wrong. So for the last one, it will be what?
6.25.
6.25. Now, multiply by probability. 156.25 times 0.3 will give us what?
46.875.
Hmm?
46.875.
46.875. Second one,
2.5.
22.5.
Yes. One is
Last one,
1.875.
1 point.
1.875.
What is the total? That's the variance. The total will give you the variance.
71.25.
71.25. So when you take the square root of variance, you get standard deviation. So I'll take the square root here. Square root of 71.25
8.4.
is what?
8.4.
8.
8.4.
8.5. 8.5. So you have gotten this part of the formula. This formula here. You have gotten this one. We are now left with what? With this covariance. Covariance AB. Covariance AB. So how do you compute covariance from this type of question? When you have a question like this, where the two investments have the same probability, your covariance is simply deviation of A times deviation of B times probability. So the summation of that will give you the covariance. Let me show you what I'm talking about. You know, this investment B and investment A are having the same probability. The probability are the same. So if you are faced with this situation, if you want to calculate covariance, your covariance will be equal to this. Covariance. Covariance AB. Covariance AB will be equal to division of A. This is the division of A. Shall you see it there? This is division of A. Can't see it. The division you computed here. That's what we mean by division of A. So division of A times division of B. Division of A times division of B times probability will give you covariance. Will give you covariance. So what I will simply do is that I will bring the division I computed earlier. I bring them down. Give me the division of A. What do we have as division of A? 10.2, Abby? Yes, what next?
1.2.
1.2. And what next again?
Minus 11.8.
Minus 11.8. These are the division of A. We bring division of B. What are the division of B? Division of B is 10.5.
12.
Okay, it's 12, Abby. 12.5.
Minus 7.5.
Minus 7.5. Mrs. Chiwa, are you there?
Yes, sir.
So, and the last one is what? Minus 2 points. Is it minus 2.5 or 2.5? This one here
Minus 2.
is minus.
Minus 2.5.
Minus 2.5. Minus 2.5. So you bring the probability. Probability is 0.3, 0.4, 0.3. You now multiply the three together. Multiply, yeah. 10.2 times 12.5 times 0.3 will give you what?
38.25.
38.25.
Minus 3.6.
Minus 3.6. Okay. 8.85. 8.85. You will now add these three. Add the three together. That is your covariance. So, covariance AB is equal to, you say what?
43.5.
43.5. That's the covariance. Now, I cannot go and calculate my what? My correlation. And bring down a formula. I know my covariance now. I know my standard deviation. So I can calculate my correlation. So correlation will be covariance AB, and my covariance AB is 43.5. What is the standard deviation of A? Standard deviation of A is 8.57. 8.57 plus 8.5. So covariance AB will be equal to 43.5 over 8.57 plus 8.5 is what? Add these two together, what do we have? Add the two together, what do we have?
0.01.
17.01. 17.01. You will now divide. We are divided 43.5 over 17.01. We give you what?
$2.56. 2.56. 56.
I'm coming. I think there's mistake somewhere. Okay. Sorry. This is supposed to be times, not plus. Sorry. This is supposed to be times. That formula is supposed to be times. Hope I didn't make that mistake. So see it. It's times. So you can see.
Okay.
It's supposed to be times. Please change it.
Times. When times it is 72.33.
72, I mean.
0.33.
2.33. We are now divide. What do we have?
0.60.
0.6. That is the correlation coefficient. That is the correlation coefficient of the investment. That is the correlation coefficient of the investment. Okay, we are not done with the question. The question says, let me look at the question again. Explain how a portfolio should be constructed. Okay, calculate the correlation of A and B and assess the what. So it's two requirements in one. Calculate the correlation between A and B. We have done that. The second part is what? Assess the degree of the risk of the portfolio in one above. So risk of portfolio. How do we measure the risk of our portfolio? To measure risk of portfolio, we are using a formula. The formula is a bit long. Risk of portfolio. I'm not sure whether this formula is part of formula sheet. I'm not sure. Risk of portfolio is given as square roots of, okay, let me write this one. Risk of portfolio. My battery is down. Okay. Risk of portfolio. Let me save this so that I will not lose my document. 1 minute. Portfolio theory and CAPM. Yeah. Portfolio theory and CAPM. So risk of portfolio. What do we use to measure risk? Standard deviation, Abi. Don't forget. So if I say risk of portfolio, I want to compute standard deviation of portfolio. That's what it means. Because I told you that to measure risk, you use standard deviation. To measure risk, you use standard deviation. So if I want to compute risk of portfolio, it means I want to compute standard deviation of the portfolio. And standard deviation of the portfolio is given as variance of return on A, that is, variance is the square of standard deviation. The square of what? Standard deviation is variance. So variance of A times weight of A times weight of A times weight of A. Variance of A times weight of A. I'm giving you the formula here. It's a bit long. Plus variance of B, which is a, let me put A here so that it will not be confusing. Variance of A. Variance of A okay, so that's variance of A times weight of A plus variance of B. Variance of B. Just put this one, I put B. Variance of B. Okay. Variance of B times times 1 minus weight of A. 1 minus weight of A. 1 minus weight of A square. 1 minus weight of A square. That's not all. Plus 2 times standard deviation of A. 2 times standard deviation of A times standard deviation of B times weight of times weight of A okay, times weight of A times weight of B. Sorry. Weight of A times weight of B, which is what? 1 minus weight of A square again. The formula is too long, Gary. Square. Then times covariance AB. Okay. Times covariance AB. Times covariance AB. This is the formula. Don't forget that your covariance is what? Standard deviation of A times standard deviation of B. This one here. Let me come and put it there. Note. Note. Covariance AB. Note covariance AB is equal to standard deviation of A times standard deviation of B times this. Okay, so what you have here, small one here, this. So you should know in a formula where you see this, some textbook you see this instead of this, but it means the same thing because that covariance there, this how to calculate it. You understand? That's why you can use them interchangeably depending on your choice and the data you have available. So using this now, I can assess my risk of portfolio. The risk of my portfolio will now be risk of portfolio is equal to square root of all this is equal to square root of, what is the standard deviation of A? Standard deviation of A is what? Please give me. What is the standard deviation of A? Hello? Are you sleeping?
No, sir.
What is the standard deviation of A?
That
Standard
deviation
deviation
of
of 8.57.
8.57.
So I put it there. 8.57 square. What is the weight? The weight you computed earlier is 40%, which is 0.4. Then plus standard deviation of B. Standard deviation of B is 8.5.
44.
8.44. Oh, okay, 8.44. 8.44. 1 minus weight of A. 1 minus weight of A is weight of B.
Sir, are you not with your this thing? Your charger? Madam.
Battery low.
That's it. My laptop went off for him and save. Madam, good night.
Good night.